So about 2 years ago, we acquired a company called Zinwave, which actually is a fiber optic distribution company. So this would be traditional DAS. So the idea is you can also, instead of repeating from the macro network outside, you can actually have a base station or a neutral host put into the IT closet of any building, and then it becomes the signal source. Imagine a femtocell or a carrier base station being there. It's a mini macro inside the basement of any large building or large facility.
With probably a hard line backhaul
Correct,
for
right. There'll be a fiber optic backhaul to the carrier's network or multiple carriers network.
Right.
And then we actually then would provide the fiber optic infrastructure to propagate that signal throughout a building. Could you imagine a 50-story office building? They'll have a fiber optic pipe from each carrier into the basement. There would be a base station for each major carrier. And then those base stations would connect to our fiber system and then be propagated throughout the whole building on each and every floor at every location.
So your fiber distribution would then go to your access point
Correct.
where that are deployed to provide.
Correct.
So is that like a MO-RAN then?
Um, no, I would call it a distributed antenna system. That's what it typically, it's really a traditional DAS.
Are you sharing antennas or are you actually having unique antennas by carrier?
Yeah, so they would be all one antenna because our system is really unique in that it broadcasts the radios in those access points, broadcasts from 150 megahertz all the way up to 5 gigahertz. So we can actually simultaneously transmit any frequency along that range. So whether it's two-way radio or T-Mobile, Verizon, AT&T, and as these carriers in the 5G world start aggregating multiple bands, because Verizon, for example, has 5 or 6 bands that they operate on, we can actually transmit and carry or distribute every one of those bands simultaneously throughout the building. So we have real world examples where in large enterprises, through that carrier aggregation, we've been able to get over gigabit speeds on multiple carriers simultaneously throughout the building. And the only way that's going to happen is aggregating multiple amounts of spectrum, right? Because it's just a physics problem, right? You need a certain amount of spectrum to be able to get a certain data throughput on RF.
So a single set of radios, that saves a lot over having every one of the providers come in and deploy their own radios within these environments, because that's the big problem these days. And it sounds like, correct me if I'm wrong, you can cover two-way, then you're covering public safety then.
Absolutely, absolutely. Yeah, we can cover public safety, two-way radio, all carrier signals, both LTE, traditional LTE, and the mid-band, which is being covered by the 5G. And the really great thing, to answer your long-winded story about what's happening cool or new in Wilson, is the private network. So you've heard a lot about private 5G networks, and they're operating over CBRS or other licensed spectrum. You can do it either way. And because we cover that large frequency range, we can plug our private network in parallel or right next to the public cellular networks. So that one common infrastructure that's distributing signals throughout the entire building, that's connecting the building, hence Wilson connectivity, can carry private and public networks simultaneously.